Okay, so here's problem 7 from the WebAssign, and so they want to know if this series converges or diverges. And as I'm looking at it, I'm seeing it's alternating, so I want to go ahead and do this just because this is what I prefer to do if it's alternating. I'll put the alternating part right there in the front, so that's -1 to the n plus 1 times 1 over 2, and that's n to the 7th in the denominator. So for this problem, b sub n is 1 over 2 n to the 7th. And if you like, you could go ahead and factor that 1/2 totally out of the problem, or you could leave it right there. It doesn't matter. If I leave it right there, then I'll look at this whole thing as b sub n. And of course, since it's alternating, I'm thinking of the alternating series test. Think AST. And for AST, the series converges if, no, that didn't work too well. Okay, so the series converges if b sub n plus 1 is less than or equal to b sub n for, the theorem says for all n, but for all n eventually. And that certainly is true on this problem though, because I would have this 1 over 2 times n plus 1 to the 7th. Is that less than or equal to 1 over 2n to the 7th? I'll put a little question mark there because that's what we're trying to answer. And that is true for all n, because the denominator here on the side on the left is getting bigger and bigger and bigger. So the fraction's getting smaller and smaller and smaller, getting closer to 0. This is the first part of AST. The second part is this. What about the limit as n approaches infinity of 1 over 2 times n to the 7th? That is 0, since the denominator again is getting bigger and bigger and bigger. The fraction is getting closer and closer to 0. So I meet the conditions for AST. This series converges. So with the estimate for the sum, how many terms do we need? Looking at the theorem in the book, and pretty much if I find what b sub n plus 1 is and it's smaller than my error, then that's I don't need that many terms. Let's see what we have here. So how many terms to get a partial sum within 0.00005 of the real sum. The real sum, we would call it S. So here's the second part of this problem. And for that, I'm just going to look at a few terms. We'll write out a few. Let's see what I have. I have the sum as n goes from 1 to infinity of -1 to the n plus 1 times 1 over 2 times n to the 7th. So the first term, when n is 1, that's 1 plus 1 is 2. It's a positive term. So the first term is 1 over 2 times 1 to the 7th. The second term is 1 over 2 times 2 to the 7th. The third term is 1 over 2 times 3 to the 7th. The fourth term is 1 over, but what did I mess up with? There, I didn't put him alternating. Okay, the first one's positive, second one's negative, third one's positive, fourth one's negative. So the next one's positive, 1 over 2 times 5 to the 7th, and then minus 1 over 2 times 6 to the 7th plus dot, dot, dot. Now, I really need to look at this probably in terms of the decimals.